a driver, what all different prerequisites you have in order to write the driver. For writing a driver, first thing you need to know is kernels C. Now, when I take this name of kernel C, the first question which I get, do I need to learn the new language for this? Like means the C which is for the kernel C? Actually not. What happens is when you are into the kernel space, the kernel C means C without standard user space libraries and headers. That means you're not supposed to use printf, you're not supposed to use strcat, you're not supposed to use strcpy, whatever usual functions you have been using in the user space, you're not supposed to use those things. Okay, so that means what are you left with? You are just left with a pure C. That means for loop, 32 keywords, and all those things. What comes in the purest form without the libc library. So the first rule of thumb when you are working and writing a driver is that you will have to boycott using the user space libraries. User space libraries till now, whatever applications you have been writing, pthread create or pthread join or creating a process, all those things are not available in the kernel at all. Okay, you need to boycott using them. That's the first thing. So now the question comes is that means do I need to write everything from scratch? strcat, strcpy, then printf, all those kind of things? Yes. So the answer to this is yes. But now the kernel, as you know, the kernel developers are very cautious and they don't want you to duplicate the code, commonly used code again and again. So over the period of time, what they did was they developed something called lib. I told you in the Linux kernel source code that I will be letting you know about the lib. So lib is nothing but a library of commonly used function. For example, over here you are going to find string. Okay, string.c, which will contain strcat, strcmp, and all those kind of things. So all the code which you require to write a driver will be the part of kernel itself. You don't have to look anything outside. So kernel is one which will be providing you the headers under include Linux, and here you'll have to refer all the header files. The prototypes will be here, and all the commonly used functions inside the lib. So this is going to be a library, and headers you will find in user include Linux. Sorry, under the include Linux. So that means in order to compile my driver, let's say I'm doing I want to compile a kernel module outside of the kernel. So kernel headers are the most important thing. Kernel headers, or I can say the kernel programming construct, because linking will be done dynamically during the runtime. So you basically need all these stuffs to write your driver. Kernel source code is a prerequisite. And in order to do that, we are going to see that like when our makefile is such that it will be referring to the kernel's makefile. Till this point, the things are clear. Any doubts?
Pradeep, what about that constructs at kernel programming constructs? What does it mean?
Kernel programming constructs is basically all those facilities which you need uh, from the kernel. For example, there is something called the wait queues from the kernel. Then you basically have the mutex, you have the semaphores, okay, semaphores, and all those kind of things, all those facilities, we call it as a kernel programming constructs, okay, which can be something like a data structures and the APIs. So
Okay.
typically when you are in the user space, you use the user space programming constructs, like you use something called uh, you use basically pthread create. Those are programming constructs. Pthread hyphen t, it's basically a programming construct, it's a data structure. So on the similar lines, kernel programming constructs are available in the kernel source code. That means APIs and the data structures.
Okay, got it now.
Yeah. Okay, so now what we are going to do is we are going to see how does the basic minimal driver looks like. Okay, how will our basic minimal driver look like? So for that particular thing, we basically need to understand the basic skeleton. And Linus Torvald, if you ask me, is a big fan of object oriented programming. And if you want to see something which is written in C and it follows the object oriented things perfectly, it's a kernel source code. Everything is being returned with the help of following those object oriented programming things. Of course, it's not a C++, so you can't use directly the overrides, the virtual and all those things, but the way it has been developed is the code has been written in a beautiful way where it strictly follows the object oriented kind of programming. And one of the I can say proof to that thing is in every driver you will have something called the constructor and destructor. Okay, constructor, as the name itself suggests, is something which gets invoked when your module is initialized. So for example, when you go to C++ or object oriented programming, constructor is something which comes into picture when you instantiate the object. Okay, when you instantiate the object. So similarly over here, when you are doing a ins mode, the constructor is invoked. The constructor is invoked. Okay, sorry, not construction, constructor is invoked. And constructor looks like this. Every driver will have the constructor which gets invoked. And how do you register your constructor? You basically use the macro by name module underscore init. To the module underscore init, you provide the function which you want to act as a constructor, and it will be doing that particular stuff. The counterpart of this is destructor. Now, what does the destructor do? Destructor is invoked when you unload your driver, or let's say if it is integrated as a part of kernel, when your kernel goes down, when basically you reboot it or you basically power it off. At that point of time, the destructor will get invoked. Yeah, go ahead.
Sir, am I audible?
Yes, yes, pretty much.
Sir, in the previous slide, when we are writing the kernel using kernel C, like in this case, do we also include the GCC means excluding all the
Yes,
components of GCC compiler, right?
yes, you're right. You're right. You're right. So typically there are in a GCC needs to be tuned. In a GCC, we'll have to specify the option hyphen hyphen no standard lips and hyphen no standard INCs like this. Okay, so this is how the standard libraries and everything are headers are being discarded. Okay,
Okay, sir. Okay.
yeah, good question. That happens. So typically in the kernel's makefile, this thing happens. Under this LKDD, you have got the something called first driver. This first driver, you will have the makefile. Okay, you are going to have a makefile, and everything is being set. One thing which I want to tell you is we are pointing it to the build. Okay, build. This build is nothing but a symbolic link. A symbolic link to user source kernel headers. So those headers will be available to you, and as a part of your installation itself, if they are not available, basically if you are using Ubuntu, it should definitely have it. If not, you will have to install the headers, the kernel headers for the corresponding running kernel. Okay, but typically it would be there, and in the makefile it is pointing to this build. And yeah, go ahead.
Sir, in the make file, can you please open the make file?
Yeah.
Yeah, sir, in the kernel source, we are adding in our the address that location of our local system, right?
Yes. Yes.
So while let's say if I am building for Beagle Bone, so
Hmm.
do I need to add the same location?
No, it won't be for the same. It will be the kernel which will be built for the Beagle Bone Black. For instance, this. So you'll use this path.
Okay, okay,
Okay, the kernel which is built for that architecture.
okay,
Okay, but this is for our system. So all those things we'll be doing on the system. So now what I will be doing is I'll do make. Okay, and as a result of make, what I will be getting, I'll be getting first driver dot ko, and I need to basically do the ins mode of this driver. When I do ins mode, it goes through, and I'll be doing the, just put, let me put 5. You see over here. Now you see a signature or something like this because I have basically disabled the secure booting. So you might have to disable the secure booting or something for this to work, because by default secure booting requires the signed. That means you will have to do the signing and all those things. But for our experiments and all, we are not going to go in that direction. So that's why you see we are getting this warning, module verification failed. So from the BIOS, I have disabled the secure booting. That means it's a normal booting kind of thing. Otherwise, it won't allow me to, because I will have to sign it for that. Yeah, that's a different story, but make sure you disable it. If it says like module loading failed because of signature, make sure you disable that. Okay, and now you see I have got MFD registered. MFD register is a part of this. Now when I do unload first driver, sudo rm mode first driver, in a D message I will get MFD unregistered. So on loading, the constructor got invoked. On unloading, destructor got invoked. And when I do load and I do ls mode, do I have ls mode head minus, sorry, let me put it 5. So first driver is in. When I do rm mode, first driver is gone. So this is your first assignment which you need to try. Of course, if there are any settings or anything you need to do, need require, typically it should not be, it should compile as is. The only thing which I am which I am envisaging over here, with where there might be a problem, if secure booting. So your virtual machine, if you are using, it might happen that in that virtual machine the things are not working. Okay, uh, then you need to disable the secure booting.